Let us study chemistry together with CBSE Chemistry Tips and Tricks.
Hi everyone, this is the third part of our daily NEET series. Question number 1 from 2023 NEET paper. In one monal solution that contains 0.5 moles of a solute, there is, you can check the options. For doing this question, you must know what is the meaning of one molar solution. It means 1 mole of solute is dissolved in 1000 gram of solvent. 1 mole in 1000 gram of solvent. Right. Now as per the question, how much mole we have? 0.5. So what should be the mass of solvent? X. Cross multiply X into 1 is equal to what? 1000 into 0.5. So what is that? X is equal to what? 500. Correct? 500 gram of what? Solvent. 1 mole in 1000 gram of solvent. So of course 0.5 mole in 500 gram of solvent. Clear, right? Question number 2 from 2023 NEET paper. The IUPAC name of the complex. See, they have given the complex and we have to find the name. Here you can see the cationic part and anionic part are coordination entities, right? Okay. For solving this question in 20 seconds, you must know 2 tricks. Trick number 1. See, you already understand there are 2 parts, right? Cationic part and anionic part. Cationic part, you can see a silver atom, right? Ag. You can call it as silver itself. Now, anionic part, again, you can see Ag, right? That you cannot call it as silver. You have to add ATE with Latin name of silver. What is Latin name of silver? It is argentum. Modify the end part of the name with ATE and it will be like argentate. Argentate. Okay. So this Ag you have to call it as argentate. Clear? Now trick number 2. For that you must know the coordination number of Ag in cationic part and anionic part. We can check that. See, on cationic part, what is the coordination number? What is the number of ligands associated with Ag? It is 2, right? Now, hint is this one. If the coordination number of Ag is 2, then its oxidation number is +1. Okay, note it somewhere. Very important. Okay, very important. Now, check the anionic part. What is the coordination number? Again, you can see how many ligands? 2. So coordination number is what? 2. Correct? You remember the hint, right? If the coordination number of Ag is 2, then oxidation number of Ag is what? +1. So for cationic part and anionic part, the oxidation number of Ag is 1. Now when you write a complex compound, when you write the name of a complex compound, first what you write? Cationic part or anionic part? Of course, cationic part. So check the options. Okay, we need silver. So silver you can see here, 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 here. Everywhere you can see silver. Now, what is the oxidation state 1? That you can see only here, right? Only here. Correct? On option 2nd and option 3. Now, on cationic part, what is the ligand? H2O. H2O means aqua, which you can only see in option 3. In option 2, it is cyanido, which means CN group. That is wrong, right? That is wrong. So, cationic part, you have to call silver. You can see silver, right? You can see silver. Oxidation number is 1. And what is the ligand? It is H2O. 2 H2O is there. Now, coming to anionic part, what you can see? You can see silver, but you have to add ATE. So, you cannot add ATE with silver. So, you have to use the Latin name, argentum. So, you got argentate. You can see argentate. What is the oxidation number? It's 1. You can see 1. And how many ligands are there? 2 ligands. Which are the ligands? See CN group. So dicyanido, argentate 1. So perfect answer is 3rd one. Clear, right? Hope all of you understand. Now what are the hints? Hint number 1. This is the hint number 1. Okay. Now hint number 2 is regarding the oxidation number of Ag. If the coordination number of Ag is 2, then oxidation number is +1. It is a major hint. Okay. Remember it, note it somewhere. Question number 3, a numerical from 2023 NEET paper. At 298 Kelvin, the standard electrode potential of See, they have given the standard electrode potential of copper, zinc, iron and Ag. Okay, on the basis of standard electrode potential, predict which of the following reaction cannot occur. See, they have given some displacement reactions. Okay, 4 options you can see for displacement reactions. Okay, for solving this question, you must know 2 things. Then you can do this question in 20 seconds. Point number 1. See, if the reduction potential is highly negative, then the metal is highly active or highly reactive. For example, see, if you check these 4 values, which one is maximum negative? It is for zinc, right? Minus 0.76, which means zinc metal is maximum reactive. So that is the most reactive metal in this list. Which one is next? Fe, right? Okay, so Fe is the next reactive metal. Then which one? Of course, it is copper, and the one which is maximum positive will be the least reactive one. Got it right? That is point number 1. Okay, so we got the activity order. Zinc is maximum reactive, then Fe, then copper, then least reactive is what? Silver. Got it right? Now, second point. This is something which you know from class 10. A more reactive metal can displace a less reactive metal from its salt. Okay, so check the first reaction. Fe, copper. Which is more reactive between Fe and copper? Fe is more reactive. So Fe will definitely replace copper and you will get FeSO4. Copper will be displaced. See, this reaction will happen. No doubt in that. Second, zinc and Fe. Who is more reactive? Of course, zinc. So zinc will replace Fe and you will get ZnSO4. Fe will be displaced. This reaction will happen. Third one is what? Copper Ag. Which is more reactive? Of course, copper. Copper cannot displace by silver because silver is less reactive. A less reactive metal cannot displace a more reactive metal from its salt. Not at all possible. Got it? And check the last one, zinc. In this list, zinc is the maximum reactive metal. Of course, it displaces copper from its salt and you will get zinc sulfate. Copper is displaced out. Clear, right? So third is not possible and question is which one cannot occur? Third one cannot occur. So that is your right answer. Clear, right? See, the one which have least negative means the one which have maximum negative reduction potential will be the most active metal, and the one which have maximum positive reduction potential will be the least active metal. That is the hint. Also, you must know more active metals displace less active metal from its salt. Fourth question is from 2023 NEET paper and it is about IUPAC naming. Okay, very easy question. For this type of questions, just number the longest chain in the appropriate way and directly go and check the options, okay? That is how you have to deal. So it is very clear that this is the longest chain, right? This is the longest chain. Okay, start numbering from left to right. 1, 2, 3, 4, 5, 6. 6 carbon in the longest chain. Now you can see that on 4th carbon you have OH group. Okay, now number in the opposite way. 1, 2, 3, 4, 5, 6. Now you can see 3rd carbon you have the functional group OH. So of course you have to choose from right to left. Clear, right? Why we are numbering from right to left? See, the rule is like this. While numbering the carbon chain, the carbon atom bearing the principal functional group, here it is OH, and we are talking about this carbon, should be assigned the lowest possible number. Which are the numbers here? 3 and 4. And which one is smaller one? 3. For getting this number 3, you have to start counting from word to word, right to left. Clear? 1, 2, 3. That is the rule. Okay, right? While writing the IUPAC name, you have to keep some points in your mind. Okay, before that, see in the question here you can see just a free line. I wrote CS3, okay, that is not there in the question. Okay, so to avoid confusion, if you see a free line, there you can write CS3. Okay, right. Now, while writing the IUPAC name, you have to write branches as per the alphabetic priority. Now here, which are the branches? You can see bromine. Bromine is branch, right? CS3 group is a branch, correct? Methyl group, correct? Methyl group. Okay, bromine, bromo, correct. Now you have chlorine, correct, chloro. You have to write in the alphabetic priority. So which one will come first? Bromine will come first. What is the position? Position is 1, right? Because we are counting from right to left. So 1. So position number 1 you can see bromine. Position number 4 you can see methyl. And position number 5 you can see chlorine. Now which one you have to write first? Alphabetic priority, of course, bromine, A, B, right? Then chlorine you have to write, not methyl. Okay, see, methyl is M and chlorine is C. So write bromine first, then chlorine, then methyl. So where you can see that first position you can see bromine, 1 bromo. Then you have to write chloro, but what is the position? 5. 5 chloro. Now position 4 you can see methyl, that you can write at the end, 4 methyl. After writing the branches, we have to start writing the name of the parent. What is the parent? 1, 2, 3, 4, 5, 6. 6 carbons, so hex. Hex, H-E-X. Only single bond, so AN. And third position, we have OH, so OL. 1 bromo, 5 chloro, 4 methyl, hexane, 3 all. Got it right? Perfect. 4 is the right answer. Moving to the last question of this video session. Okay, and that is from 2023 NEET paper. Choose the correct statement. See, they have given some statement regarding graphite and diamond. For doing this question, you must definitely by heart this table. Okay, and definitely see there will be some question regarding graphite and diamond for NEET exams. Okay, anyhow, we can check the option one by one. Diamond is covalent and graphite is ionic. See, it is incorrect. Okay, both diamond and graphite are covalent. They are covalent allotropes of carbon, and there is no ionic bonding in graphite. Remember it. Okay. What is the second statement? Diamond is sp3 hybridized. Correct. Okay, in diamond each carbon is sp3 hybridized, forming 4 sigma bonds in a 3-dimensional tetrahedral structure. Remember it. Okay, so how many sigma bond? 4 sigma bond. What is the type of structure? 3D tetrahedral structure. Got it right? And about graphite, of course, it is sp2 hybridized, forming 3 sigma bond. Remember, 3 sigma bond. Okay, with 1 delocalized pi bond in 2D hexagonal layer or sheet. Okay, right? Understood? So there is 1 delocalized pi bond. Remember it. In the case of graphite, there is 1 delocalized pi bond. Due to that, see, the graphite is a good conductor. Remember it, okay? Due to that, the graphite is a good conductor. So, of course, the point number 2 is correct, right? Diamond is sp3 hybridized and graphite is sp2 hybridized. Correct. So, that is our right answer. Now, we can check third and fourth option also. What is third option? Both diamond and graphite are used as lubricant. No, only graphite is used as dry lubricant due to its slippery layered structure. Remember it, okay? Diamond is very hard and abrasive, not suitable for lubrication. Remember it, okay? Remember, you can see that point here. Okay, now next one is what? Diamond and graphite have 2-dimensional network. We already understand diamond have 3-dimensional and graphite have 2-dimensional. So wrong. Only second option is right. Hope all of you understand. By heart this table properly. Okay, very important.